Hello everyone, let's take a look at our next problem. Find the sum of all positive two-digit integers that are divisible by each of their digits. Okay, so two-digit integers divisible by each of their digits. I wonder if we can narrow down exactly which numbers satisfy that and eliminate a lot of them. Okay, so we can eliminate all multiples of 10, right? The number 30 is not divisible by 0. Is there an easy way of doing that? Another thing we can do, we can eliminate all even numbers where the tens digit is odd. We can eliminate all of the 50s except for 55. So here's what I think I'm going to do to approach this, is actually just go through all of the numbers, I'm going to go through all the teens and all the 20s, all the 30s, and just sort of start knocking off the numbers that don't satisfy this property. And I don't know if we're going to be able to find a pattern, but I think this process might not actually take that long. I think it should be very easy to just mentally cross off the numbers that don't work for this. Okay, so for the, all the numbers up to the 40s, I just went through them one by one and did it very quickly. You can, of course, in this column, for example, I can immediately cross off all the odd numbers because an odd number will never be divisible by 2. Similarly here, I can cross off all the even numbers. Wait a minute. No, even numbers can be divisible by 3. What am I doing? Okay, so I've obviously made some mistakes here. Let's go through this column again. 36 is divisible by 3 and by 6, so that was a mistake. 39 is not divisible by 9, though. Okay. Although this is correct in this column, I can cross off all of the odds. They will never be divisible by 4. 44 is clearly divisible by 4, and so is 48, but none of the others. All of the numbers in the 50s column, none of them will be divisible by 5 except for 55. And then it starts to get easier once we get into these larger columns. 60 is divisible by 6, but not 0. The only other number in the 60s then that will be divisible by 6 is 66. So you can get rid of all the 60s. Something similar happens in the 70s, 80s, and 90s. It's only going to be the multiples of 11 that stick around. You can see that if you look at the 80s column, for example. 80 is divisible by 8, but not 0, so it's not included. But then the only other number in the 80s that is divisible by 8 is 88. Okay, so let's just go ahead and underline all the numbers that we have to add up here. So the way I'm going to do this is we clearly have all of the multiples of 100 from 100 to 99. So I'll add those up first. We have 100 times 1 plus 2 up to 9. So this will take care of 11. Oops. This will take care of 11, 22, 33, 44, and so on. And then we just have some sort of stragglers around. 12, 15, 24, 36, 48, and that's it. Okay, so I'm just going to do the arithmetic here and hope that I end up with the right answer. Okay, I end up with a final answer of 630. I'm fairly confident in this. I mean, a lot of addition going on here. It's possible that I made some silly errors in that arithmetic. And maybe I had some kind of silly oversight in crossing off one of these numbers. I don't think so, though. I'm going to go through really quickly this table of numbers again and see if maybe I've crossed off or crossed off one that I shouldn't have. Yeah, so going through this again, I think my selection of the numbers is correct. And if I did the arithmetic correct, then this should be the right number. So fairly confident in this answer, but if I find a mistake or if I have any additional comments, I'll put them in the description below. Thanks for watching.